All right. Hi, everyone. Welcome. We are at 102, so that's a pretty decent courtesy curtain for everyone. It's nice to see faces and names, many people who are joining us again, and some people I see are joining us for the first time, so welcome. This is the Broadway Green Alliance Green Quarantine Learning Series. We are now well into the summer. This is a regular thing, and it's nice to see so many people. We are back after a 1-week intermission with a really fantastic session today with an incredible host. We are very lucky to have here with us Ian Garrett to be doing a deep dive into sustainable lighting design. So welcome, Ian. Ian is a designer, producer, educator, researcher. I had to write it down. He does so many things and I didn't want to miss one. And he is the co-founder and director of the Center for Sustainable Practice in the Arts. So we have a fantastic leading expert in the field here today. So without any further ado, I want to turn it over to Ian. I will note a little Zoom practice. The way we manage these, as you will see, we sort of cheat the Zoom webinar system so that you are all panelists and can turn your video on so that we can have a robust discussion at the end. As you have questions as you go, put them in the chat and we will moderate them at the end. Though be prepared, I will likely ask you to turn your sound and video on and ask your question live. So thank you so much. Ian, I will turn it over to you.
Thanks, Molly. I'm watching like panelists come in, and I'm sure that or everybody attendees, however we want to frame everybody. But noticing everybody come in and the number of familiar faces, it's like all of a sudden it's like, oh no, now they're gonna find out that I have no idea what I'm talking about. Which is like that's just working in theater. That moment before you turn on all the lights, my experience as a designer is like, oh, this is the time when they figure out that I'm a fraud. Anyway, thank you very much for the introduction. Obviously, like I've been fooling them for long enough to put together. I'm going to share a presentation. I do tend to talk fast. Like flag me. I'm not sure how I'll see it, but let me know if it ends up going too fast because I just want to cram in too much information. I'm sure. I think so. I'm going to share my screen with you now. Let's see. Let's get there now, and I want to make sure because there's a couple of videos in there that I've got computer sound on. Great. All right. So hi, as Molly said, I'm Ian Garrett. I saw a number of people who are now staring at me because I've got the small thumbnails on the side of my screen here going forward. I work as in a number of different capacities. I usually frame what I do as what I don't do. I'm not a performer. I have no interest in performing aside from talking as myself. So as a designer working primarily in lighting and media, but also in set and spatial and general scenography, it's taken a number of different forms in theater spaces and not. I'm a father. I have 2 small kids. When one of them was much smaller, you can see him sitting on my lap at a tech table in the upper center of this as well. I'm going to be talking about a couple of projects here, which, though this is about lighting design, one of the projects that I'm talking about, I did more of the systems design. My friend and colleague Simon Rossiter was the actual lighting designer on there, but we work closely with each other. So when we start to think about lighting systems and how we think about efficiency and an environmental approach there, that will frame it. I teach at York University up in Toronto. That's what brought me Toronto, where I'm coming to you from today. Traditional lands, the Anishinaabe, the Haudenosaunee, the Métis, the Huron-Wendat, and currently treaty holders, the Mississaugas of the Credit First Nation here. So that's the land that I'm pleased to work on and be a guest to, though I'm originally from the States. I taught lighting design, media design, and devised theater there. Sometimes my son comes in. Again, he's in the upper left-hand corner there to help with rehearsal when it's possible. I co-run a small production company that does work around bridging mixed reality and theater. So this has been a frame of a lot of our work recently. It's called Toaster Lab. We walk around with a lot of funny devices that look like ears and little robots and do a specific performance. That tends to be the way that that frames together. And on top of all of that, I do research and more traditionally academic work around arts and the environment in conference settings and writings about it, etc. So today we're talking about lighting, and what I want to do is actually go through like 3 larger case studies, just looking at different approaches to thinking about sustainability within the lighting systems there. 2 of them are on the creative side, and one of them is more a systems approach. So if you're thinking about it either as a designer, perhaps in different frames there, or thinking about it in managing a facility, or thinking about capital project or things like that, hopefully there's something in each of those for you in here. And then taking a look at some of the topics that are interesting to me in terms of the direction that the field is going, and different things and considerations as a designer that have that are on my mind when we're starting to look in this direction, because there's always this give and take between the technical benefit of working in a sustainable way, like the metric benefits of efficiency in that regard. But one of the reasons that we work in theater and work in the arts is not to be efficient. That may or may not be the core concept, but it can't necessarily always be the core concept of what we're doing. We have to serve dramatic texts and other types of performance and dance, and support the vision of those, and we can still integrate our thinking around green and sustainable practice that way. So the first project that I want to talk about is called Ascension. It was actually the large-scale installation. It was commissioned in 2010, so it's now aging a little bit, and used some early LEDs. I served as a lighting designer on that, and it was for the Coachella Music Festival. I'll start with just a short video that sort of starts it from the project lead for the overall project. There were a couple of different teams and lighting in here, so we'll start there.
Nick came one day and he said, guess what? I just had a meeting with a couple of guys from Coachella and they're looking for some projects, some ideas. And the only thing that they said was that it needs to affect the skyline. Got a little packet going on, built a little model, did some computer drawings and so on and so forth, and sent in the packet. The next day, got a response back, and they said that we want it bigger and taller. They weren't quite sure that we could pull this off.
Pull down the volume on that, because I think us trying to stream it at the same time, the playback's getting a little cut back. And really what I wanted to bring us to anyway is this moment of giving a sense of sort of the size of it as well. And you can see some of the lighting fixtures on it. This was an opportunity where in primarily having worked within a theatrical context and starting to think about from the early 2000s of sitting in technical rehearsals and thinking about efficiency, and could I power the design that I was working on at a moment with renewable sources and solar. This became an opportunity where someone was like, well, let's try and see what we can accomplish through doing that. So you saw some of the development in there, and dramatic cuts and pans within there. A little bit of the structural rendering in here. It's made out of 12-inch aluminum truss, primarily, with some custom fabrication in it. It is, because it's in a desert valley, which has these huge temperature shifts over the course of the night, it's got these driven points in the abdomen and wingtips, which are about 150 feet apart, so that it could withstand hurricane force winds. You know, the obvious thing should be that if you are designing something to look like a bird, and in a windy area, it has the ability to take off over time. And it uses a 70% textiline shade fabric as the skin for it, and a little bit more of the anchoring as well. It became important to light it as well because it's in this large, the Coachella Music Festival takes place on the Indio Polo Grounds, and so it's this large open desert area. There's not a lot of cover around it, and they do a lot of projects and commissioning around things that have a certain sense of scale for, you know, the tens of thousands of people that come over the course of that concert and its sort of companion country music festival Stagecoach that happens so over the course of 3 weeks typically. As that, this started out as thinking around it as the like a shade structure that was going to be on the field there. So there's a lot of solar analysis that went with it, but obviously concerts oftentimes ended up happening in the evening as well. So we had to do all this planning around what we wanted to look like, and essentially the brief came to me as a lighting designer as we want to be able to look at it as one solid color. So there's a couple of challenges here where we have to start thinking about different types of lighting technology as well, primarily looking at architectural units, but this is let's say early-ish days and a lot of LED technology, at least in a theatrical application as well. So we're starting to experiment a lot with how we can actually illuminate this, because we also can't do anything with the structure around it, and importantly, have to provide our own power. Another challenge is that we would never see it in person until it was actually constructed on site. So a lot of it happened through visualization. So this was the early, decade ago visualization of taking engineering files and doing the renderings. Also, many LED lights don't necessarily have the same like point, source, spot quality to them. So being able to do more traditional photometrics is not as useful, and more so now with some of the many of the lights that have been adapted for theatrical use. So a lot of engineering work going into the back of it, trying to come up with a rendering that we would hope would look like this. Our basic goal was to provide this even wash of lighting across the entire surface and do the modeling to get that as close as possible with these different fixtures. Here, you saw the aerial view of it, but you can see it in installation here, and you have it shortly constructed, and you can maybe notice towards the right behind it there, it's just sort of in the shadows here. I'll sort of jiggle my mouse. Hopefully that's coming across as well. But if we turn around there, you see that there's a solar array that's been installed behind it. So we designed this to charge a set of deep cycle batteries. I'll point them out in the next photo. But it became this whole conversation around what is the system by which we can create this isolated lighting. We couldn't pull power from the festival. We couldn't bring a generator into the space. And we wanted it to showcase a number of renewable technologies. With the solar studies that we had done, it actually would have been more efficient, and we would get more power out of putting these panels flatter to the ground because of the solar exposure. But in this turnaround, you can see we also wanted to create something that people would gather around for it. And if you want to know where the batteries are, there's sort of a white box in between the seating here, and that's where all the batteries are. There's a channel with all the power sort of dug in across. So it becomes a second opportunity to provide shade as well. We sacrificed a little bit of efficiency. So as the sun goes down, the power flow to the batteries is reversed. We turn off the solar and turn on the battery so it flows through to the lights themselves. So they're coming up as we get to dusk, and we've energized those. We had estimated a power ceiling about 6,000 watts, 6 kilowatts, and planned for the system to actually completely drain the batteries. Now, one thing that this brings up that's interesting in terms of thinking about lighting design as we move from an incandescent individual source and work with color medium and providing using gels as color filters to remove parts of the visual spectrum, because we have this additive multi-source lighting coming out of the LED units, that in these being RGB units, relatively straightforward, whenever we wanted one of those saturated colors, it actually would only, you put the red at 100%, it would only use 1/3 of the power, because you've got your blue and green at 0, using no power at that moment. Whereas especially to get some of the more saturated colors, if we were using more traditional white light with a color medium in front of it. We'd be looking at generating more power or requiring more power to be able to get to the same level of luminosity. And so this becomes an interesting thing for us in the course of doing this project, is that we've got this power ceiling that we've established based off of the maximum draw of the fixtures that are installed on this unit. And we end up never using it, actually. Due to the nature of the consumption from an LED source, it's nearly impossible to use the maximum unless we left it in white the entire time. So with these three emitters, it ultimately didn't shut itself down by the end of the day. I like this shot because it sort of gives us a little bit of a comparison between those early renderings and where we are here. And it resulted in someone having to go and shut it off at night, which adds another interesting sustainable question around our sense of what's successful. Because if you were to go out to the concert grounds after everybody's cleared out, you can see all the refuse that is at the bottom here. So this becomes a first attempt at getting into this idea of working with extreme amounts of efficiency in an ambitious project. This moving it into a theatrical realm, I had the opportunity of working on a project called Vox Lumen here in Toronto, which was in 2015 at the Harbourfront Center in the Harbourfront South Theatre. Here, I was engaged initially to consult on the energy component to it. Based off of that experience with the Ascension project, there was a desire to go completely off grid with an in-theater experience here. So this became another example of extreme engineering. I didn't serve as the lighting designer on it. I ended up being the scenic designer on it. I mentioned that before, that Simon Rossiter is the lighting designer on her, but we ended up working really closely with each other. Hopefully this, I'll pause this video if it has the same sort of glitchy aspect to it, but I've got a short video introduction that the Harbourfront Center put together to talk a little bit about the process, which gives you a sense of what the production was like.
We're taking on a lot of risk with putting this production on in this way. We can design the systems as well as possible, but until we put everything together, we don't know if it's going to work. I've been on this project for nearly 2 years now. William's been developing it for longer than that, I think 3 or 4, since the initial idea came to him. And he originally came to Harbourfront, to Tina and Linan, to I just asked for advice on how to approach a project like this. We knew we would probably be working primarily with energy efficient lighting sources, but beyond that, there wasn't a clear, like, we need to use this product or this technology. So a lot of the experimentation has been, will this product and this energy solution work together?
With this project, we're looking at efficiency. We knew that we'd be looking at newer units, but there's not necessarily a preset way of working. We also wanted it to work within the overall design of the production, the overall scenography of the production, so that there was a constant give and take between how it was generated. We had an initial idea that perhaps we'd be creating our own bike gym in the lobby of the theater, trying to actually get enough people to charge those consistently was difficult, and it ended up also here going with a solar solution. We ended up having an energy fair outside of it as well that was showcasing various types of alternative energy ways of energy capture as well. When we were moving this over to the design aspect and all this was working together, we were looking at ways in which we would integrate the lighting into the set itself. This is actually the second version of the set. We went through 27 iterations as well. So in addition to this electrical question, we wanted to express this as a design. We ended up changing it over time to continually evolve sort of something that would capture a sense of enclosed energy, to open up the space a bit more. At one point there was projections involved, and that's sort of where these tensile fabric structures come from. One of the things in terms of efficiency that sort of comes across in the aesthetic, both in terms of working on the energy component of it and the design element for it, is how do you start to work with a set design that is also efficient? You start thinking about efficiency across all of the different aspects of it. So insofar as it's concerned here, it's also about how do you fill that volume, or give a sense of volume, while you're also working with materials that can break down a bit. That pushed us to, in this situation, to move down to an even simplified form. We had this overwhelming mass that this piece of fabric ended up cutting video from it and turning it into a fiber optic branching system. And we've got a rendering here. At the same time that we're developing this, though, each step along the way in the scenic design, in the lighting design, is a conversation that gets very granular insofar as looking at the systems, because we sort of know, again, that we're throwing out the ability to use a perfectly good theater to use solar capture. So this is from the Courtright Conservation Center. The Conservation Authority here, for demonstrations, has this solar trailer that they've done out of converted utility trailer that has solar on it and it's full of batteries. We also partnered with a company that has a less, they essentially make solar charging stations for like pedestrian malls, so you can go and charge your phone, and it's not connected to an external power source. They actually broke things down, so you can see their panels on sort of a makeshift 2x4 wood frame. It's been gated off behind here, and then we use their batteries and inverters using their power system. And this becomes a really interesting part of this as a lighting design, is that oftentimes we walk into a space and there's an assumed infrastructure, and we know a power ceiling in terms of like when a breaker is going to flip. But in terms of working with batteries and inverters, you're dealing with a much smaller amount of draw. It depends on the ability of those inverters to change from the DC current in the batteries to the AC in the fixtures, which is sort of ironic, because even though a lot of our LED fixtures would really benefit from a direct current power source, they're built to then convert it to that out of an AC current, because our dominant infrastructure is done in alternating current. So you need to invert it, and that means that you're constantly having this conversation about what's on at what time to be able to talk about this. Sometimes you might have run into this in even like a fringe setting where you're trying to be more ambitious with the lights and you're swapping patching and things like that. You have to have the same sort of approach to doing that, because you end up with a much stricter power allowance, and as opposed to flipping a breaker, there are other sort of effects, and you also have to then be concerned about the draw over time. Whereas if you trip a breaker on a dimmer rack, you're able to flip it back, you can pull down the draw, but it's going to be consistent amount, like source of power, whereas the batteries over time are going to be drawing down. So you start to calculate all of those elements as well. We also have this challenge of how you get the power inside then if you're dealing with solar. So all of these are on carts, chained down so they wouldn't go away, and moved in pre-show as well. And so this became like a workshopping process of how do we start to integrate different aspects of lighting into this, and rethinking not just light as we're going to bring in a lighting designer towards the end. We were engaged fairly early in working on the process in a series of workshops, but not just bringing it as an end to light over everything that's going on, but because of the very particular nuances and needs for being able to accomplish design in this way, that we had to constantly be going back and forth with what was possible. We had hoped at one point that we would have like a really close relationship with a manufacturer. They ended up doing a little bit of custom lensing for us. Like they 3D printed a custom lens for us for one unit with AC, and allowed us to use some of their equipment. But it was finding the right piece of equipment for the moment becomes, and what I find within sustainable design tends to be true, is that really the process of efficiency you might prioritize using one piece of equipment over another, but really what's happening is you're making a very specific choice. And the ability to make a specific choice, regardless of what piece of equipment you use, informs how you get to the best choice for that moment and in that scene. So you can sort of see it come together here. A couple of just glamour shots there. And I like this photo because you can sort of see everything on, or almost everything on, where we integrated lighting into the mast itself that's in the base, finding different areas in which we're talking about light and power within the choreography itself. You can see the use of mast through these tensile wiring that were to fill the space, but that also dancers could enter as well. And so you end up with this dialogue between senses of efficiency in specific moments in there. It takes a little bit more time to do, and it was difficult to do, especially with coordinating all the dancers' schedules as well. It's a little bit perhaps more contained version of this and not my project. I'd point to a project like Jupiter, which Superhero Clubhouse in New York did down at La Mama, which caused them to install a set of solar panels on the roof there down on 4th. And in this, they sort of actually split the difference between having a system that was solar powered and a system that was conventionally powered, so that they were also using it for dramaturgical effect. But one of the things that you run into with this is that if you don't generate enough electricity or store enough, then eventually things turn off. Whereas, and you can see in both of the previous projects, we actually end up over designing for that with multiple backups to being able to do that. They integrated it into the show, so there was always a level of illumination that would happen in the conventional sense, but also be able to draw down over time. So this is sort of like the creative balance between things. I wanted to also jump into something that's a little bit more facilities oriented, to look at another way of thinking about how this comes together. And this is a project that ended up, though it's also the university that I teach at, I was brought in to consult on how to retrofit our lighting inventory across all of our spaces in the School of Arts, Media, Performance, and Design at York. Showing our larger theater here, another glamour shot. Tends to be the type of thing that the department likes to put on the website, but we have multiple studios in this space that were coming together. And we were actually coming to the end of the life of a lot of equipment in these spaces. The buildings were open in 2006. There was another theater space on campus that was condemned due to asbestos and has yet to reopen or be retrofitted in 2008, 2009. And as a result of this, the last time that there was an influx of new equipment was with the opening of the new building, and a lot of equipment that had been in use had been inaccessible for a long period of time. So we were working with a lot of legacy equipment as set for what was in the new spaces. And having come to over a decade of operation, the manufacturer for that equipment also was not supporting it in the same way anymore, and we were having trouble finding parts. So we took this as an opportunity to reevaluate how all the systems together. Looking at just that bigger system, that bigger space in one of our primary theater producing spaces, our studio theater, our existing house plot, our repertory plot in each of those, were coming in at this level of energized load, about 170 kilowatts and just under 50 kilowatts respectively. But through going through a process of reevaluating, rethinking the way that we were lighting these spaces for efficiency, we are actually able to bring that down quite a bit. Going for about, across all of our spaces, around a 90% reduction in energized load, which also then means that our actual load is going to be a significant reduction as well, but we don't necessarily have data on use. There's not a lot of sub-metering that goes on across the spaces, and we don't necessarily see that as a direct expense anyway, so you can sort of see that moving across here. And part of the reason for this was because, and this is the house plot in our studio theater, which also we cleaned up the drafting for, it hadn't happened in a long time, was it took a lot of things out of operation and really simplified a lot of the ideas in there because of various features of current contemporary efficient lighting. So whereas a backlight system might consist of a couple of 1K Fresnels and a scroller to be able to change colors, in a lot of areas we were able to replace this with one individual LED unit. you do have to rethink the way that color works in this sort of space, but it allows us to go from over 2 kilowatts to just around 100 watts. What makes this, in our situation when we're thinking about facilities, extra interesting and brought on a lot of different partners is that we were initially looking at this in terms of primarily around power reduction. We're also looking at this in terms of expendables such as gel and color medium, and then also looking at the rate at which we have to replace lamps. Once we brought it into our campus partners and were able to talk about what was there, they started looking at it also in terms of the HVAC load, in that there's less heat generated that they're mitigating over the newer fixtures that we're working with, just in the conversions there. So they're bringing on the stress on the cooling systems. Sometimes there's a little bit more heat involved as well. That also translates into stress on other systems around the building with that heat gain and temperature change and humidity control. That becomes easier for them to manage with moving to more efficient units. And that means that they're actually seeing longer duty cycles on other equipment, whether or not that's generalized lighting around the space or other sort of mechanical systems in the space, because that temperature has a significant impact over it. We also have this reduction or a reduction in the liabilities associated with health and safety. We have fewer trips to each lamp, and because, especially here in Ontario, where we're subject to Ministry of Labor regulations that require, and we teach to this, though in an academic setting it's not necessarily required, we teach to a professional certification standard for working at heights, that this allows us to bring that down. So it changes our insurance, it changes things like that as well. And it becomes a source of community education as well. Our central services and building operations, the facilities department, you actually got it to be featured as the campus's, like the centerpiece of the campus's last sustainability report, because of the significant savings that they're calculating across all of the different spaces. Though a lot of the investment in new equipment went into publicly rented spaces and typical performance spaces, the other thing that it allowed us to do that was really useful was to actually cascade a lot of fixtures. So like I said, we had a lot of legacy equipment around, especially in our smaller studios. Work is developed. So as we're able to move to a lower powered lamp for the same illumination and perhaps better optics, then we are also seeing significant reduction across all of those spaces, so that we ended up with this really willing partnership with our power utility, that we're really sort of impressed with the amount of change that we can make. So one of the considerations that I pointed out with this is that in many spaces, when we're looking at replacement, we're looking at a reduction going from a legacy fixture. Just happen to have a color trend. That's a lot of what we had in our, but regardless of what you're working with, if your main goal is power reductions, you can go down to, this 575 watt lamp. And where we already had 575 watt lamps, we were going down to at most 167 watts in those areas. When we have these legacy Fresnels, well, that's supposed to be double hang, but doubled up with a scroller, total wattage for that is 2,170 watts. And then we're moving that over to, depending on the space and the application, moving that over to 150 watts, depending on the type of color engine that's in the fixture, or down to 90 watts as well. So a significant reduction in there in the multiple factors. Where we haven't done a direct equipment swap, we've been looking at other types of equipment that actually ask us to think about how we're using the light in a different way. So not that we've taken any of them, they were just announced, but I've been really interested in the Color Source Spot Junior, because I think that there's a criticism levied to them that they're a simplified fixture. Similar sort of thing happened with the Source 4 Junior anyway. They are for really like a narrower amount of applications. But it's interesting because when we think about those health and safety considerations and its long duty cycle and something that doesn't have to be visited as often, it starts to take those into consideration with something that also adds a little bit of safety because it cuts the weight in half. and assumes that you might not be going to it as much or changing as much, but gives you a lot of the features that you might want. The source forward is an adapter kit to actually come up with a point source replacement, taking off the back of a traditional source for, a tungsten source for, and changing it over to a white LED unit. You still use the color medium, but you end up with a significant power savings of that as well. And then, not to make this an advertisement for ETC, though they do have really fantastic LED equipment, also a big fan of the Chroma Q line, because they've been doing a lot of work for a long time in terms of really advanced optics and the way that they blend together, especially in their wash units. That has actually changed, as you look at them, changes the way that you might think about designing with the lights. We have conventions in the way that we approach lighting design within North America. We like sharp shutters, whereas you might see more profile units in Europe. And I think that's also one of the changes, is that the way that the light comes out of these fixtures is different in such a way that there are other creative opportunities for working with them in that way as well. Sort of getting to, so this is sort of an overview of a couple of different approaches that I've had the pleasure of working with to come to a more efficient place. I wanted to cover a little bit of the basis for why this. So I want to spend the last little bit of time here talking a little bit about infrastructure and embodied carbon, well, specifically embodied carbon air, but infrastructure, and then some of the other design considerations that start to crop up with this. This is the US transmission grid. It's not much of a grid itself. And what's interesting about each of these colored lines is that they're incompatible power sources. They're running at different voltages, so they need to be transformed to go to one or the other. And infrastructure is a big issue everywhere, but this is an aging grid. One of the reasons the US and a lot of North America is still on 110 to 120 volts is just because it's older. And there's a lot of legacy equipment there as well. But as we're thinking about this infrastructure, a lot of our actual infrastructure has turned more to this, which is this is a visualization of the surface level of the web. So we've lost the sense of like where actually physically things are. A lot of our processes have become invisible. And whereas we once sort of, these are two opera houses. You've got the Sydney Opera House in its probably current form on the left-hand side, and a very full and not current Seattle Opera on the right-hand side. Though on the left, we've all, if you're working in technical theater, we've all spent time in a theater more occupied like this. The HVAC systems, the mechanical systems are designed for comfort at a filled state. And these have significant impacts as well. So that's one of the biggest considerations when we're thinking about efficiency, is actually not just the efficiency of the lighting itself, but how it interacts with everything around it. Because everything has an amount of energy or carbon that has gone into the material extraction, its transportation, manufacturing, transported to you, goes into use, and then needs to be disposed. And all of this becomes part of the life cycle of that product. There's the cradle to gate, the amount of it that before it gets to the actual user of it. But by the time it gets to you, there's actually an amount of embodied or embedded energy or carbon, depending on which it is, that has had a significant impact. That like a lot of laptops, once they get to you, have consumed the equivalent of 2,000 kilowatt hours of electricity from transporting them, extracting the materials, and shipping them around, which has a significant impact on the atmosphere that at normal density as CO2, and CO2e, to clarify, is CO2 equivalents, which is to reduce everything down into a common unit. So it introduces other like methane and sulfur, but converted into carbon units, that occupies a significant size of the atmosphere. So that when we're thinking about all these infrastructural solutions, that even the emails that we're sending on a day-to-day basis have a significant, have a measurable impact on our carbon footprint because of the background infrastructure that's going into it. So it's a thought that we have in terms of the way that we construct the spaces and the way that we as designers or lighting technicians may be working in these spaces and thinking about our impact, that it's not just about the efficiency of what we're working on, but the efficiency of the overall system working together. Jumping back to the Harborfront Center Theater, when they went to reglaze their atrium, the lobby space, because it's a glassed-in space in southern Ontario, so it was always freezing in the winter and sweltering in the summer. They went and integrated a photovoltaic system into it that also worked with a glass artist to think about it. So started thinking about the infrastructure as not just we have to do this for plant and facilities operation, but how do we integrate this with the artistic priorities of our stakeholders. You know, there's a number of changes to infrastructure that we end up thinking about as we make these conversions. If we're looking at LED specifically, we're looking at running more data as opposed to power. We're seeing buildings change in that way. Much smaller dimmer racks and much less copper are going into new facilities because of the assumption that most of it's going to be taken over by LED. Still providing room for it because LEDs aren't like, there's not a one-to-one replacement out there in the field. There are still really important usages for more conventional tungsten fixtures. But we're seeing a lot of the infrastructure slim down a lot. And as we see these reduced HVAC loads, we actually see smaller studio spaces, and not smaller spaces for the actual activity in the studio, but especially in like television studios, they've been able to cut the ceiling down by feet because they're not having to have, when you're in a television studio, lights tend to be on at full, and all the heat from that needed somewhere to go. And so they mitigate a little bit of the HVAC load by also having high ceilings to trap that heat. With the reduction you've not just got the reduction in the load, but you're able to actually have an increased amount of space. You're not actually losing any usable space. You're losing volume of space that was previously used for heat management as well. So we're seeing, like, you're seeing these systematic shifts happen. When it happens architecturally, it happens over time. So, you know, the artistic projects and even this inventory refresh that I highlighted are really about things that are working in existing infrastructure, but that's going to be more and more easily accomplished. There are a number of considerations about starting to do the conversion as well that I think are important to talk about. One is color reproduction. I'm sure for most people on here, this is going to be a little bit of review, but you know, there's different, whether or not you want to use CRI or different color quality indexes, but looking at CRI as it tends to be printed, is that a lot of our non-incandescent sources are not reproducing the full spectrum in the way that we want. That even when we get to a high CRI LED lamp, we're still getting around 95. So we're not getting the full visual spectrum in there. And that has an effect on the way that we see it, on the way that we feel about it. Similar with color temperature or correlated color temperature, because we're not actually dealing with in Kelvin most of the time, but there's a different sense of the way that we perceive the light that's happening. And we see this happening in our homes. You know, they say the lighting facts that the US Department of Energy has put on most of the light bulbs that are available now. So we have to think more about those things. The light coming out of a lot of these fixtures just isn't the same. So we've got a couple of different spectral graphs here. One on the right-hand side is actually from ETC, referring to their 7-color system. And you can see the curve of the included visual spectrum within a tungsten lamp versus different color systems on the right-hand side. And that these gaps are things that we feel, that we sense. If you look at the left-hand side in this bottom left-hand corner, oftentimes what we're trying to overcome with the advancements of the last decade in LED lighting is getting away from these really sharp spikes, which work on reflected surfaces or work when we're dealing with televisions in reproducing those sort of colors and backlighting those. But insofar as casting on things and the way that light is absorbed doesn't work in quite the same way, where we're most happiest looking at something in terms of sunlight or in a warm sense towards an incandescent light. One of my favorite projects out there in the world is this one called Room for One Color by Olafur Eliasson, which is impossible to really comprehend without going into it, where it has a negative CRI, where it only reproduces one color, and you see that color and black and steps between it. And so it's a really unsettling environment to be in. And so we have a physiological and psychological response, not just to an individual color, but the amount of the visual spectrum that's available for our brain to process and its feeling of the natural in there, which you can see across a number of different CRIs. When we get into video, that's fine. because a lot of times LED color gamut of the RGB works fine working over the video color gamut and what the camera sees, but it's still missing from our eyes. You can see sort of one of the changes in studios that I was talking about here. And our body processes and takes information from this light in different ways. Blue light has an effect on our circadian rhythms. You can see here that blue light is very prevalent in sunlight and goes down in incandescent light, and definitely goes down in candlelight. So that's part of one of the triggering responses, although it's a little bit more tied to just overall brightness. But it is one of the things that when we get down here into the white LED, that this becomes something that has been documented as being able to disrupt things like sleep. It has benefits in that it's made it really efficient to do indoor farming. So a lot of plant and grow lights for indoor farming have changed over to something that we perceive as more being a pink or magenta, and combining things at the extreme ends based off of like a very specific mixture of wavelengths that are good for photosynthesis. But it becomes hard when we get into things like light therapy. It's changing part of how our aesthetics overall work. Not that this is lighting specific, but there was once research that was showing that fire trucks were more noticeable in this yellow-green color. But then a lot of areas changed back because of the cultural associations with them. So there's an aesthetic choice between the actual scientific recognition versus the cultural recognition. And it's changing the way that our cities look. This is an overhead of Calgary, changing over from sodium to LED street lighting. Here's a comparison of the same street in Ottawa and Los Angeles. You know, it's a different, this is the same scene, same moment in the same show done in two spaces, one with LED lighting and one incandescent. You know, a small show, but something that allows you to see in a very specific condition the difference here and how it changes the feeling of those. We see all these other saturate colors happening as well across that we previously would have been uncomfortable for us to work with. And I think one of the things, and this is my last image, but one of the things that I think is so telling about how the shift is happening is that I have had the opportunity to work with Don Holder a few different times, including when a lot of early LED products came out. And there was a lot of resistance on his end to doing an early LED conversion because for those who are familiar with the lighting plot of the Lion King, the drapes on the wings, the framing, are done with light boxes essentially, and the color quality and the color reproduction, though close, wasn't quite there. But it's something that has been changed over in just the last couple of years, and starting with the touring companies to move that over. And so it took that long for the technology to catch up with those things and get to that energy goal that Disney Theatrical would have been pushing for. So there's a lot to consider when starting to think about working efficiently. Thanks for letting me yell at you for 50 minutes about energy efficient lighting. Happy to take questions.
Thank you so much, Ian. That was incredible. And those images were, at the end in particular, I'm going to be thinking about for quite some time. They're really striking. We have a question. We have two questions from Ross in the chat. Ross, do you want to unmute yourself and ask those questions?
Yeah, well, yeah, okay. Sorry. The first one was had to do with the batteries, and how much margin do you leave in those batteries for safety, or do you design a separate system for safety lighting?
So we're using completely, when we're using those batteries, we are using a completely secondary system for the safety lighting. Okay. So that there are cues, you know, similar to in any space, generally, like if you lose data connectivity, like if you lose DMS signal, a lot of dimmer racks are set up to maintain the last state so that you can sort of figure out what's going on. A combination of that, in that performance, we also did design a fail-safe. Because of the extreme power limitations, there is actually enough power still in the room. we didn't take out the electrical infrastructure so that you could plug it into the wall, because it essentially used could have been run off of 320 amp circuits, the way that it was ended up designed. And a lot of that, even though there was more than that as a connected load in a conventional way in which you would have done it at one time if you plugged everything at one time, because of programming around the power distribution that worked. But that being said, there was still both the safety systems within the theater itself as a completely secondary system, and unless the question is more towards do we leave room in case we're experiencing more draw, and the answer to that is yes. We're always designing for to stay within the capacity. So say that we always we aim to have about 70, only draw down the batteries to about 70%. They also start to drain at different rates when you get down to lower amounts. You'd see that also on the way that especially with the inverters, they're not as smart, but your laptop battery drains at a different rate and changes the way that it distributes the power when you get down to the smaller when you start getting to lower amounts out of a safety measure. So I don't know if that's a couple different ways of. Is that the same?
No, that was great. I assumed it was secondary system. I was hoping it was a secondary system. Are there any real world experience? Have you hit those safety margins, or I'm sorry, not the safety margin, but have you gone real close to running out of power? And if so, what did you have to do? Did you have to shut down systems? What did you do?
We haven't, because we've been so overly cautious that we've had yet to do that. And in fact, with the first project, we ended up with the opposite problem where we actually wanted it to shut itself down. Because it wasn't the light that people needed to move around, but it was sort of timed out at a certain amount of draw, and that caused us to have to go and shut it down. So I've more so had the opposite problem, but that's being extremely conservative with the power, of not wanting to do that, because we're still dealing with show critical systems, right? What is our experience with doing that? So there's always that sort of attempt. So that's not to say that we've come up with a formula for preventing it. We're probably capturing much more power and designing the drawdown to be so far within it that we're not tempting fate thus far.
And this is a little bit off subject. Have you had to support an LED wall doing with batteries yet?
I haven't done a full LED wall, no. I mean, that's and thinking about that and why I chuckle is the amount. I could imagine doing a small LED wall, but getting to the full size of that would be tricky. The Vox Lumen project, a lot fewer lights in the air. It doesn't appear like that from the audience because they're timed out. There's probably more than if we just use pure power, but still a lot less than we would had we approached it and just gone with the theatrical system. We don't design to the theatrical system. It's a constant back and forth. So tiny LED wall I think would be easy. I imagine the amount of draw as you scale that up gets tricky.
Great, thank you very much.
Great, thank you. And I see, Robert, thank you for your comments and thoughts in the chat there. Sorry, Charlie? Do you have oh, okay.
Yeah.
Does anyone else have a question? Feel free to click on and unmute or raise your hand. Great. I would love to know then, anyone here, I see we have a lot, I recognize some production managers and designers here. Has anyone done anything with an LED switch or solar panel lighting? I'd love to hear a success story or a challenge that you encountered while trying to get this done.
I'll point out Rob
Yeah.
is making some good comments in the chat too, and because I know that a lot of his work is as a consultant on things, and there's a lot of diverse considerations when making the switch that aren't just about the light coming out the front.
That's great. Rob, do you want to click on and share those?
Click on and share those. Okay. Do I click that one there?
Just share them.
You're on, Rob. Go for it.
You're on, Rob.
Okay, whatever. Read the chat. I just said some things over there.
Great.
my job is being a theater consultant, so we put new systems into either new buildings or renovated buildings. And lots of people do long spreadsheets with a lot of math to figure it all out, basically to justify it, because these swaps are not cheap. But there's long lists of advantages that go way beyond just saving on the electricity. A lot of people seem to concentrate on that aspect, but we did a bunch of complicated spreadsheets, which involved me researching the longest formulas I've dealt with since I was in school. And they were about calculating how much you save on your air conditioning, because most theaters are air conditioned, sometimes even in the winter, depending on how your HVAC system works. Some of them don't take advantage of cold air outside. They make cold air with electricity on the inside, which sounds crazy, but anyway. And so one of the things that nobody concentrates on is how much you save in your air conditioning. Mm-hmm. And a rough rule is that it's equal to what you save on the electricity. So earlier you were featuring how many watts you were going to save per light, and it's a factor of about you spend about 1/6 as much electricity on the new stuff, the LED lights, than you used to spend on the incandescent. And there's a similar reduction in your air conditioning load because of that. And it works out to the same price, the same amount of dollars in electricity. So actually, you can very easily calculate how much you're going to save on your electricity by the wattage difference. Just take that number and double it for the HVAC part, because that's approximately how much you're going to save. And then there's all kinds of other differences that Ian mentioned. But LED lights have some downsides that no one ever wants to talk about. And they're not downsides that affect everybody. They're just downsides that affect some applications, so they're not universal problems. One is the lights weigh more. They're heavier. Each light weighs maybe 20–30% more because it's got essentially a whole computer and a bunch of other stuff, the power supply thing you mentioned, in the back of the light, whereas the old incandescent lights were rather dumb instruments that didn't have a lot of stuff in them, just a wire going to a socket and a light bulb, and that stuff didn't weigh much. Now, weight for each light matters on things like, you have a long truss and a festival that's 100 feet long and you want to put some lights in the middle. Well, how much each light weighs starts to matter for the structural thing there. But for lots of applications, the weight doesn't matter. Another one is noise. Most of the LED lights have some kind of fan in them. You can buy the ones that have no fan, but then they have gigantic heat sinks on the back, and then they have more of a weight problem. So if weight's okay, but noise isn't, maybe you buy that one. I'm thinking of places like concert halls or recording studios that might have some lighting in them. And those are the places where if you bring a fan in there, they will crucify you. So you don't want to be doing that. And there's some other things to watch out for. The color game is the most complicated one and most delicate, because people pull out all kinds of flaky words to describe what's wrong with the lighting. Here's how I get around it, and I know it's a cheat, but it's the only thing I've managed to figure out what to do these days, and I just make all the lights match. That is, they're all the same brand, the same series, and then there are no color problems, because the eye is very forgiving. It makes up for all kinds of things that it sees and auto corrects colors. But if you start mixing an incandescent light with an LED light or different brands and models of different LED lights, your eye starts to go, hey, that one's bluer or that one's oranger or something right away. But you eliminate that problem if they're all the same brand and series. But that only works.
Thank you, Rob. I'm sorry, we're at time, so I'm going to jump in here.
I'm going to say my last word is that only works until the day I walk out the door, and then they go buy different lights and screw it all up. Okay, that's all I have to say.
Thank you so much. Thank you for those thoughts. Ian, do you have a sentence or two you'd like to leave us with as we are at the end of our session?
I was in a brief add something onto Rob there. That's also one of the reasons to be cautious of like really inexpensive equipment, because also then you get variation across the binning of the LEDs there. So it's good to work with it. And a lot of this becomes about LEDs and efficiency, but also one of the reasons to bring up that embodied carbon idea is that a working light that you don't need to replace. There's a lot of environmental impact that you've already absorbed into doing that. So if you can keep something in operation as opposed to buying something new, that's also always actually a good approach to taking to it. And it's ultimately about making those really conscious decisions in the design to move forward. And it will be interesting to see in our COVID times how that's going to continue to change, given the way that it might change our spaces.
That's great. Thank you so much, Ian. Thank you for sharing your knowledge. Thank you, everyone, for participating. This was a great and informative session. If people have continued questions or thoughts, please, you can send them to me. We can keep the conversation going. And you can certainly connect with Ian at his website. Ian, will you say your website?
Sure, it's sustainablepractice.org, and I'm at Ian at sustainablepractice.org.
Thank you so much. We will be back here next week. The next two conversations are going to continue on this train, and especially for those of you in the design and production world, we will be digging in even further on this topic. It will be a two-part series focused on sustainable production. We will be exploring what that means, particularly going forward as we think about reopening our spaces in this, I'm not going to say post, in our COVID world. What does that look like in regards to sustainability, and how do we keep this momentum forward? So I encourage you all to come back. They're going to be discussion-based format, so come ready to share and learn together. And then at the end of July, we are going to be hosting a conversation on environmental justice with an educator from We Act in Northern Manhattan, another conversation not to be missed before our August recess, when we can all relax. So thank you again. Thank you, Ian. And I hope to see you all next week. Take care.
Bye, everyone.
Thanks, Ian.